Hello everyone, welcome back to this class. In this video, we have introduced you the process how to reduce ER diagrams into relational schema. And at the end of the video, a relevance exercise is provided to express how to complete it. In today's lecture, more exercise will be provided, and finally, a brief summary for these chapters will be demonstrated. Okay, now let's start today's lectures. First, let's move on the next exercise. In this exercise, you can use the ER diagrams completed in the previous exercise and tries to reduce it into relational schema. And now, let's review the whole scenarios of this case. This case is the interview results for a company, and the whole scenario is similar to the previous exercise, except a little bit difference exists between these two scenarios. So now let's take a look at the description. In this company, there are several departments which are uniquely identified by department ID, and their department name and location have to be recorded. Each department owns several employees who are recorded by their employee ID, employee names, birthdays, several phone number, address consisting of city, street name, and the number, and finally, and age. The fact that the employee of department is responsible for some specific projects have to be recorded, and each project can be identified by their project ID, project name, and the budget. In the previous exercise, we have completed the ER diagrams according to this scenario. So now, everyone can try to convert these ER diagrams into relational schema. We will discuss the results 20 minutes later. Okay, now let's discuss the results of ER diagrams conversion. Here, we also follow the guidelines mentioned earlier. First, we have to find out the rectangles because they denote entity sets. In these diagrams, there are three entity sets. They are departments, employees, and projects. And we have to transform them into individual tables respectively. And in each table, we have to indicate primary keys with a key attribute. So after converting these entity sets, we can obtain three different tables: departments, projects, and employees. And in departments table, department ID is the primary key since it's designated as key attribute, and the project IDs is also indicated as the primary key of projects. As to employees table, primary key is employee ID. In addition, we have to notice the multi-attributes phone numbers exist in employees tables because in the definitions of relations, each attribute has to be atomic. So here we have to engage in more reduction here. According to the guidelines I mentioned in the previous slides, these multi-attributes has to be separated from the original table and combined with the primary key of the same tables to form a new relational schema. At the same time, both attributes are treated as primary key for this table. In addition to primary key, employee ID is the attributes come from employees table. So employees ID is the foreign keys which can reference primary key of the table. It also means one day, if users want to obtain more information about this employee, such as name, birthday, or other attributes, it can be done by this reference. After completing the part of entity set, and then we will move on the convergence of relationship set. In this ER diagram, we have to search for diamonds, which stand for a relationship set. And here, the participants relationships connects the entity sets of departments, employees, and projects. So it's a ternary relationships. And this diagram also reveals that all employees and the projects participate in this relationship. According to the guidelines revealed previously, we have to create a new table which consists of the primary key of the involved entity sets. Here's department ID, employee ID, and the project ID have to take into account this new table. We also have to consider the attributes attached to these relationships. So here, the hours value have to consider in this new table. After converting the relationships, we can obtain the tables participate, which consists not only the primary key of the involved entity sets, but also the attribute attached to this relationship. So that's each tuple of this new table and shows that the employees belonging to someone's departments participate in someone project and its duration. In addition to the part of primary key, we have to consider the part of foreign key, since its attributes come from different tables. They should be treated as foreign key by referencing the primary key of each table respectively. In other words, one part of the primary key's employee ID is a foreign key which can reference the primary key of employee tables. And another part of this primary key's department IDs is also the foreign key by referencing primary key of department's table. Project ID is also foreign keys which can reference the primary key of project table. Through the reference of foreign key, we can get more information by joining the source tables. So here we have completed the reductions of ER diagram into relational schema. After completing the relational schema's reductions of these two scenarios, I would like to make a brief comparison of them to reveal some points worthy to be noticed. In fact, these two scenarios are similar, except some difference exists in the interactions of them. In exercise 1, the main subject includes department employees and projects, and The whole scenario emphasizes the interactions between the two entity sets. In other words, the scenarios want to reveal the fact how the two subjects interact with each other. As to exercise 2, what these scenarios mentions also includes the same subjects as exercise 1. However, what it emphasizes is the interaction occurs among these three subjects simultaneously, rather than the interactions of each other. So, according to different realization about the scenario, we may produce totally different ER diagrams, just like exercise 1 and exercise 2. However, it is not the issues related to correct or incorrect. I think what we concerns is which one is more close to the fact we want to reveal. And based on these two different ER diagrams, different outcomes of relational schema will be produced. Since exercise 1 emphasizes binary relationships between two entity sets, the generated schema will reflect this fact. We can see in addition departments, the project tables contains not only the attributes related to projects, but also the attributes associated with department. And the same results also can be seen in employees table. In these tables, it records not only the employee's relevant attributes, but also the attributes associated with department. So according to the representations of these binary relationships also can be demonstrated in the relational schema. And what exercise 2 emphasizes is the ternary relationships amongst three entity sets. So these ternary relationships also can be reflected in the generated relational schema. We can see the participant tables contain three attributes. Each of them is associated with its corresponding table. So here, I would like to remind anyone who is dealing with database design had better carefully examine the relationships between or amongst the relevant subjects, because the ER diagrams you draw is approaching the real situation. The final relational schemas you design will be closer to user requirement. And now, let's go on the next exercise. In this exercise, everyone can base on the ER diagrams we complete in exercise 3 and tries to reduce it into a relational schema. And here we demonstrate the order forms again. We can see the data items appears on this document. And according to these documents, we have drawn the ER diagrams like this. In these ER diagrams, the entity sets include customers, orders, and products. For each entity set, it records its own attributes. And here's the underlined attributes denotes key attributes. In addition to the part of entity sets, we also can see the relationships exist between different entity sets. First, let's examine the create relationship. If the customer is associated with many orders, since each customer may orders many times. At the same time, each order is owned by only one customer, and here all orders participate in this relationship. So here's the cardinality mappings of these relationships is many to one, and it includes the relationships exist between orders and products. Here, each order is associated with many products because each order can contain many products, and each product can appear on different order forms. So each product is associated with many orders. Accordingly, the cardinality of these relationships is many-to-many mapping. In addition, this includes relationships has to record the quantity values. In other words, the values of quantities will vary and totally depends on these relationships that some products is included in some order. This is the horse ER diagrams, and everyone can try to reduce it into relational schema. After 20 minutes, we will discuss the generated schemas. Okay, everyone, now let's go through the process of reducing these ER diagrams into relational schema. According to the guidelines I reviewed previously, we have to find out the entity sets which represented with rectangle. Here, I have indicated them with red circle. When we convert these entity sets, don't forget to indicate the primary keys if the attribute is indicated as key attribute. So follow the guidelines. We can convert each entity set into an individual table. In general, the names of entity sets can be used as the table name and followed by the attributes listed in this entity set. And don't forget to indicate primary keys for these tables. After reductions, we can obtain three tables. They are customers, orders, and the products. Each table has its relevant attributes and the primary key. So far, we have completed the basic convergence for entity sets. And then, the relationships is the target of reduction. In ER diagrams, the relationships is represented with diamonds, and here I also indicate them with red circle. Here, we also follow the guidelines described previously. Compared to the convergence of entity sets, this part seems a little bit complicated. However, I think you complete it easily if you can follow the guideline. For many-to-one relationships, such as create, we don't need to create a new table for represent this relationship. What we have to do is just add an extra attribute from the one-size entity set. So we can choose the primary keys of one-size entity set customers and add it into the many-size entity set orders. After converting the relationships, orders table contains an extra attribute, customer code, which is the primary key of customer tables. By adding these attributes, it can reveal the relationships of orders and customers. These extra attributes also play the roles of foreign keys, since it's the primary key of another table. So by this reference, the information users retrieves is not just limited to these attributes in orders tables. They can expand their search scopes to another tables to retrieve all the attributes related to this customer. And next, let's continue converting this relationship. Because it's a many-to-many mapping relationships, we have to create a new table for expressing this relationship. We have to choose the primary keys of both involved entity sets. They are product IDs and orders IDs to form the new tables. So we can obtain the new table, which I call is orders in products. Because it's the new table, you can use any meaningful names to represent it. This table contains from the involved entity sets, and the combinations of these two attributes can also be treated as primary key. In addition to these attributes, we have to consider the quantities, which is the attributes attached to include relationship. After inserting the primary keys of the involved entity sets and the attributes attached to these relationships, we can successfully convert the includes relationships into a new table. And each tuple of this table can describe the fact that which orders includes which products and its quantity. In addition, we have to notice the foreign key of this table. Since these two attributes come from other tables, they have to be treated as foreign keys. One foreign key is order IDs, which reference the primary key of orders table, whereas another foreign key is product ID, which will reference the primary key of products table. With the add of foreign key, we can expand the search scopes to obtain more these orders or these products relevant information respectively. After reducing the ER diagrams of order forms, these four relational schemas can obtained. Through this exercise, I think everyone is supposed to be familiar with the skills of how to draw ER diagrams according to a certain scenario and how to reduce the ER diagrams you draw into a relational schema, which can form the basis of database. And next, we'll explore some design issues for insurance everyone can possess better design capability. If everyone can understand the methodologies I mentioned, I explain for the reductions to relational schema. Now, I will introduce some design issues. First, let's examine some common mistakes usually occurs when we draw ER diagram. In the first examples, it reveals some incorrect use of attribute. The key attribute is absent for each entity set. The key attribute's ID should be indicated by underlines the corresponding attributes for the entity set student, whereas the department names should be indicated as key attributes for the entity set of department. In addition, the attributes department names is not needed here because these attributes will added automatically when the many-to-one relationship is converted. In the second example, Figure B reveals the erroneous use of relationships attribute. In these examples, the many-to-many relationship student section connects the entity sets of students and the session. These relationships has attributes called assignments marks, which contains multiple meanings. So it's not suggested to have the attribute contains different meanings and put them into together as attributes for this relationship. There are some alternatives to help us correcting this erroneous ER diagram. In the first scenarios, we can consider to separate some parts of the attributes as a weak entity set. Here we separate the assignment attributes and treat it as an weak entity set. This separated entity sets can be placed between the original entity sets, students, and sessions to reveal the fact some students is assigned to some specific session. And of course, since we transfer assignments into a weak entity set, we have to add an weak relationships here to connect assignments, and it identifies strong entity sets. And here's the attributes marks is left and belong to the relationships to indicate the scores the students in this assignment. In addition, another alternative to correct these erroneous ER diagrams is to represent the concepts of multiple attributes with the format of composite attribute. For example, here is a composite attributes assignment marks, which contains assignment and marks can be created here, and these composite attributes can attach to this relationship. And now I would like to talk about the usage of entity sets and attributes. Under some circumstances, the same concepts can be represented the forms of entity sets or attributes. But which one is appropriate for representing the situations we want to reveal? Let's take a look at these two examples. The left one represents the entity sets of instructors, which contains attributes ID, name, salaries, and phone number. And here, phone numbers is just reiterated as a part of attributes, while the right one represents the same concept, but it separates the phone numbers from to form a single entity set phone. This phone entity set is associated with instructor via instructor-phone relationship. In general, these two types of representations are acceptable since they have reveals the concept that phone numbers is a property of instructor. But compared to the left one, the right one can allow us to reveal more extra information, particularly for the situations that have to indicate multiple phone numbers. As to the use of entity sets and the relationship sets, according to the guidelines I mentioned earlier, we can try to search for non or independent objects to represent them as an entity set. However, we can try to designate the relationship sets to describe some actions that occurs between entity sets. For example, if we want to reveal the fact that advisors, which is an action occurs between instructor and the students, we can represent these actions with relationship sets. Sometimes we have to consider more descriptions about these situations. So we have to consider the placement of relationships attributes. For example, if we want to use the attribute days to indicate when this student is advised by an instructor, these attributes should attach to advisor or student's entity. The days varies as different students is advised by different instructor. So here, days should attach to this relationship set rather than student's entity set. As to the choice of binary and non-binary relationship is also an important issue when we draw in a diagram. Although it's possible to replace any non-binary relationship set by a number of distinct binary relationship sets. However, compared to several binary relationship sets, an n-ary relationship set shows more clearly that several entities participate in a single relationship. Some relationships that appears to be non-binaries may be better represented using binary relationships. For example, the ternary relationships parents relating children to his or her father and mother is best replaced by two binary relationships, father and mother. And using two binary relationships can allow partial information, particularly only mother being known. But for some relationships that are naturally non-binary, the relationships project guide is a relationships involves multiple entity sets, including several entity sets such as employee, departments, projects, etc. So in this case, it's suggested to use non-binary relationships to represent this kind of relationship. And some decisions we have to make when we involve in ER design. These decisions include should we use attributes or entity sets to represent an object. Or sometimes we have to think about whether a real-world concept is best expressed by an entity set or a relationship set, and the questions of the use of a ternary relationships versus a pair of binary relationships. And sometimes we have to consider the use of a strong or weak entity set. And as what I mentioned earlier, there's no correct answers. Instead of pursuing a correct answer, what we should concern is that to represent an ER diagram which is closer to real situations we encounter. And if we complete the ER diagram which is much closer to real situations, the final schemas we obtain from this ER diagram will be closer to what users need. And at the end of this chapter, I would like to make a brief summary of symbols we use in ER diagrams. Rectangles usually denotes entity sets, and the diamonds denotes the relationship set. Double diamonds represents identifies relationship sets for weak entity sets. And the double lines between relationship sets and entity sets means total participations of entity sets in this relationship. And the attributes attached to this entity sets is usually listed below entity sets. These attributes include simple attributes just like A1 or composite attributes A2. The presentations of composite attributes we can represent more detailed elements followed by this composite attribute name. And the A3 is the multi-values, which can be represented with a pair of braces. And the A4 is a derived attribute, which can be presented with a pair of parentheses. For each attribute, we can underline some attributes to reveal its primary key. And the double lines rectangles usually refers to weak entity sets. As to relationships, there are some different mapping cardinality, including many-to-many mappings, one-to-one mapping, or many-to-one mappings. And under some special circumstances, we can indicate the role names on the lines between relationship sets and entity sets. And if it needs, we also can indicate the cardinality limits on the lines between relationship sets and entity sets. In addition to the notations I introduced in this chapter, Some alternative ER notation still can be seen in other database design applications. In order to make everyone understand more about alternative ER notations, I will spend a little time to introduce this part. In alternative ER notations, rectangles still denotes entities, and the ovals denotes attributes. Here, A1 is the simple attributes, at the same time is also the key attributes because this attribute is indicated by underlines. And let's move on to A2 attributes. A2 attributes is a composite attribute which includes two elements A21 and A22. So composite attributes can represent with the presentations like a flower. And A3 is a multi-value attribute since it is represented with double oval. And A4 is a derived attribute because it is represented with dotted line. As to relationships, first I will introduce you the chain system. In these alternative notations, many-to-many relationships can be indicated by star to stars. Here, stars means many. So if we indicated stars on the lines between relationships and entity, it can reveal the meanings of many. So if we want to represent one-to-one relationships, what we have to do is indicate one on the lines between relationships and entity. So many-to-one relationships described by indicated stars and one. And in these systems, double lines means total participations and the single lines denotes partial participation. As to another system, the relationships can be represented with different way. In this system, the symbols like chicken claws means many. So if we indicate both ends of a line with this symbol, it reveals the relationships is many-to-many mapping. If we want to represent the one-to-one relationships, we just use singles without any symbols at both ends. And if one side of the length is indicated with the symbols chicken claw, and the other side remains single line, it will demonstrate the relationships is many-to-one mapping. As to total participants can be represented with the little circle. As to partial participations can be represented with cross. And before we end this chapter, I would like to make a brief summary. In this chapter, we learn several ER notations first, and through several exercises, we also learn how to draw ER diagram with these ER notations to reveal the context of database application. And the final part, we also explore the process how to convert the ER diagrams into relational schema. I hope everyone can Learn some things from these videos, and this knowledge can help you in the future.